Okay, welcome to our solutions for finding inverses of logarithms on worksheet 1. Problem number 1 is y is equal to 6 times the natural log of x. Now here we have, on all the problems, the basic description of the inverses and the relationship between an exponent, b to the x is equal to a, and its inverse expressed as a log. Log base b of a is equal to x. X is the exponent, a is the answer, and b is the base. For natural logs, we just write ln to mean natural log, and that means base e. E to the x is equal to a is the same as the natural log of a is equal to x. Alright, so for problem number 1, y is equal to 6 times the natural log of x. When we're finding inverses, the first thing we need to do is swap x and y. So we'll rewrite this as x is equal to 6 times the natural log of y. Alright, now what we need to do is we want to isolate the y. This is 6 times the natural log of y, so we'll divide both sides by 6. So what we get is x over 6 is equal to the natural log of y. Now what we said is over here, the natural log of an answer is equal to the exponent. It turns into e to the x is equal to a. So we'll simply rewrite this as the base is here. This is another way to think of it. The base is here. The exponent is on the other side of the equal sign, and a is our answer. So what this means is, rewriting it, we have e to the x over 6 is equal to y. Well, let's change the color here. All right. E to the x over 6 is equal to y. And that's it. Y is equal to e to the x over 6 is the inverse of y is equal to 6 times the natural log of x. Let's go to our next problem. All right, this problem is going to be a little more involved, but it'll be easy enough to explain the final result. I've already rewritten the problem with x and y swapped. So now we have x is equal to log base a half of y plus 1. So continuing on, what we need to do is remember our fundamental rule. Here's the base. Base to the x is equal to the answer. So here for this problem, what we have is 1/2. Now remember, all of that is our b. So we should remember to put it into parentheses. 1/2 raised to the x power is equal to y plus 1. All right, so good. So far, so good. Now the next step is to distribute this x, because this is 1 to the x over 2 to the x. So now we have, and we'll just put it right here, put a little line, says that's what this means, okay, right like that, and we have 1 raised to the x power over 2 raised to the x power is equal to y plus 1. Good. Now what do we need to do? Well, we want to get y by itself. We'll subtract 1 from both sides. We get 1 to the x over 2 to the x minus 1 is equal to y. Well and good, but what we want to do is put all of this over a common denominator. So what is another way to express -1 in terms of a denominator of 2 to the x? Well, it's just 2 to the x over 2 to the x. So this becomes, and we'll write it right here, this becomes 1 to the x over 2 to the x. And we said this is a minus, so this is minus 2 to the x. And that's all equal to y. Now, the answer sheet you have shows something a bit different. And the explanation is fairly easy. It's all about 1 to the x. The answer sheet, I believe, says y is equal to, well, everything's over 2 to the x. It says negative 2 to the x, and it says plus 1. Well, here's your plus 1. The question is, why does 1 to the x, why is that the same as plus 1? Well, what is 1 raised to any power? It's simply 1. And what is the square root of 1? It's simply 1. What's the third root of 1? That also is simply 1. So in every case, 1 to the x is simply 1. And there's your final answer. Okay, let's move on to the next problem. Now, in the next few problems, we'll find that the procedure we've used is the same. So what I will do is I will show you the worked out solutions and quickly talk you through it rather than have you watch me write out the solutions for each problem. Okay, so here we have y is equal to log base 6 of x plus 10. First step, transpose x and y. We get x is equal to log base 6 in parentheses y plus 10. And these parentheses are very important, as you'll see in some of the upcoming problems. This means 6 to the x is equal to all of this. If the parentheses were not there, our statement would be a bit different. All right, so now we want to solve this, and as we just said, this is 6 to the x is equal to y plus 10. We want to get y by itself, so it's simple enough. We're going to subtract 10 from both sides, and we get y is equal to 6 to the x minus 10. And that's the simple answer to this one. Okay, for this problem, I have written out most of the work, but I needed to emphasize a couple of points here. First of all, if we look, there are no parentheses around the x minus 7. So the negative 7 can be considered separately from the x, and when we transpose x and y, it'll be considered separately from the y, which is the reason I moved the negative 7 over, just a little to emphasize that point. Now this is true on this side of the equation. When we get to the other side of the equation, after we have added 7 to both sides, what we need to realize is that this over here is the exponent. That's our basic rule. When you have a log 6 to the x, or 6 to the x plus 7, because that's what the exponent is, all of that is equal to our answer, which is y. Some base to the x is equal to the answer. In logarithmic terms, a base to whatever's on the other side of the equation is equal to the answer. And so after we have added 7 to both sides, we have x plus 7 on the other side. Okay, so we now can easily finish this problem because this is 6 to the x plus 7. 6, and I'll look like this with the parentheses just to remember it. 6 to the x plus 7 is equal to y. All right, now what I'd like to do is talk you through a few problems because the routines are basically the same. Okay, y is equal to log base 4 of x plus 1. Again, there are no parentheses, so the plus 1 can be considered separately. Transpose first, x is equal to log base 4 of y plus 1. Subtract 1 from both sides. Now on the other side of the equation, as we said before, all of this, the x minus 1, is the exponent. So we have 4 to the x minus 1 is equal to y, and that's our answer. Okay, simple enough. As long as we remember the power of parentheses. Y is equal to log base 2, parentheses 3x. X is equal to log base 2, parentheses 3y. So 2 to the x is equal to 3y. Then divide both sides by 3 down here, and we get y is equal to 2 to the x over 3. Problem 7. Y is equal to log base 3 of x plus 10. Again, the 10 is separate. X is equal to log base 3, y plus 10. Subtract 10 from both sides. On the other side of the equation, all of this is the exponent. 3 to the x minus 10 is equal to y. And that's how simple this is. Eventually what we'll do is we'll look at the strength of all the patterns to the problem solving so we can understand a bit more about what's actually going on. All right, in this case we have x raised to the 5th power, the log base 3 of x to the 5th power. You should remember that any answer raised to a power, when it's expressed as a log, is really 5 times that logarithm. So log base b a to the 5th is the same as 5 times the log base b of a. And we use that rule over here. First we have to transpose x and y. We have x is equal to log base 3 of y to the 5th. Next thing we can do is transpose it, move the 5 over. We have 5 times the log base 3 of y. Divide both sides by 5. We have x over 5 is equal to log base 3 of y. All of this is the exponent. 3 to the x over 5 is equal to y. Problem number 9. Pretty straightforward. This time we don't have it. We don't have x to the 9th power. We already have the 9 in front of it, so that's kind of easy. Transpose x is equal to 9 times the log base 3 of y. Divide both sides by 9. X over 9 is equal to log base 3 of y. 3 to the x over 9 is equal to y. And we're done. Problem 10. Looks like it's a little more confusing, but it's really not. X is equal to log base 3 of negative 2y. So what we'll do is say 3 to the x is equal to negative 2y. Divide both sides by negative 2, and that's really our answer. Y is equal to 3 to the x over negative 2. All you have to do is remember the power of parentheses. All of this is the answer, and we can just, so we don't move anything to the other side, and we just raise 3 to the x power, and then work through isolating y. Problem 11, here's the parentheses, so all of this is the answer. Transpose x and y. X is equal to log base 5 of y plus 4. 5 to the x is equal to y plus 4. Subtract 4 from both sides. 5 to the x minus 4 is equal to y. And our final problem. Y is equal to log base 4 of x minus 3. The only difference here is we're going to add instead of subtract. So transpose x and y. X is equal to log base 4, y minus 3. 4 to the x is equal to y minus 3. Add 3 to both sides. Y is equal to 4 to the x plus 3. And we're done. And we're ready to tackle more challenging problems.